হ্যালো স্টুডেন্টস, মিশন কেরিয়ার আমরা আস্তে আস্তে কিন্তু ভালোভাবে এগিয়ে নিয়ে চলেছি। তো মিশন কেরিয়ারের মধ্যে যে জিলেটের পার্টটা রয়েছে তার মধ্যে ইঞ্জিনিয়ারিং ম্যাথামেটিক্স এবং কম্পিউটার অ্যাপ্লিকেশান এবং তার সাথে কিন্তু মেকানিক্স আমরা অলরেডি স্টার্ট করে দিয়েছি। তো আজকে আমরা যে ক্লাসটা স্টার্ট করবো সেটা হচ্ছে স্ট্রেংথ অফ মেটেরিয়াল সোম। তো এই ক্লাসটা মেন যেটা উল্লেখযোগ্য ভূমিকা তার হচ্ছে এই যে 100 নম্বর যে রয়েছে, 100 মার্কস যে রয়েছে জিলেটে, তার মধ্যে কিন্তু মোর দ্যান 15 to 20 মার্কস কিন্তু এই স্ট্রেংথ অফ মেটেরিয়ালে থাকে। তো প্রত্যেকটা স্টুডেন্টকেই বলবো, যারা যারা আমাদের এই ক্লাসগুলো জয়েন করছো তারা প্রত্যেকটা ক্লাস সমানভাবে মূল্যবানভাবে কিন্তু এই ক্লাসগুলোকে তোমরা করবে। এবং আজকে আমাদের সঙ্গে পেয়েছি এই স্ট্রেংথ অফ মেটেরিয়ালের জন্য প্রফেসর ডক্টর সুমন দাস, মেকানিক্যাল ডিপার্টমেন্ট। এবং আমরা তোমাদের কাছে আরও ভীষণভাবে উপকৃত হব বা তোমাদের উপকৃত করতে পারবো যেভাবে, সেটা হলো এনার যে এক্সপিরিয়েন্স, স্যারের যে এক্সপিরিয়েন্স, মোর দ্যান 20 ইয়ার্স এক্সপিরিয়েন্স, তো সেইটাকে আমরা কাজে লাগাবো এবং তোমাদের কাছে যেভাবে স্যার রিপ্রেজেন্ট করবেন। এবং আজকে যেহেতু একটা প্যান্ডেমিক সিচুয়েশন, আমরা টোটাল ক্লাসটাই আজকে আমরা অনলাইন মোডে আনছি, কিন্তু আমাদের কিন্তু অফলাইন মোডেও ক্লাসটা চলছে। তো আজ থেকে আমরা স্ট্রেংথ অফ মেটেরিয়াল ক্লাস শুরু করছি। আমাদের সঙ্গে রয়েছেন প্রফেসর ডক্টর সুমন দাস, মোর দ্যান এক্সপিরিয়েন্স 20 ইয়ার্স। স্যার।
Okay, good afternoon to all of you. Myself, Dr. Shuman Das. So today I will discuss strength of material subject. That is one very interesting part of the strength of material, that is the stress strain diagram. Okay, now let us discuss. Now, before going to discuss this stress strain diagram, first of all we have to know very clearly that what is stress and what is strain. So, now let us discuss the term stress. So, in our Bengali term, that is also called the piron, and in the strain, that is called vikriti. Now, let us take a very small piece of iron rod or iron wire, and if we just apply a direct load, that is P, so what happens? So this member or this bar will try to elongate. Okay, now due to the elongation, one resistive force that will develop inside the member, that will try to resist this external force. So that resistive force is called R. That is the resistive force. Now, if we just remove this applied external load, so that will spring back this deformed state to its initial state. So with the help of this resistive force or resistive load. Now, this resistive force per unit cross-sectional area, that is called the stress. So, stress is nothing but the internal phenomena of the material. Okay. Now, if we just take the load, that is the direct load, that means from the try to elongate the member. Now, this will try to elongate, and the diameter of the member will be reduced, and the length of the member will be elongated. So, suppose the total length of the member before elongation, before the applied load, that is the L, and this is the del L, that is the length increased, and the diameter, that is the before the applied load, the diameter is small d, and obviously the diameter will be reduced. Now, so now from the strain, so we can write the stress is nothing but, so that is the resistive force divided by cross-sectional area. That is the cross-sectional area. Resistive force by cross-sectional area. So that resistive force is exactly equal to the applied load, that is the resistive force by A, that is nothing but P by A. Okay. Now that is called the stress. So this stress is denoted by the symbol that is the sigma. So sigma here is called the direct stress. So what is direct stress? Those is the directly applied on the member, that means the resistive force divided by cross sectional area. So that direct stress, so we can write, so stress, so this stress can be divided into, there are so many categories. The main broad classification is, one is the direct stress, another one is the shear stress. So one is the direct stress, another one is the shear stress. Now these direct stress can also be divided into two categories. One is the tensile stress, another one is the compressive stress. So what is tensile stress? When the member is tried to elongate, the stress develop inside the member, that is called the tensile stress. Now same phenomena, if we just compress the member, so a resistive force will be developed, that is inside the member, that will try to resist that external load. So that compressive stress is nothing but that resistive force divided by cross sectional area, that is the compressive stress. So these two stresses is denoted by the symbol, that is the sigma. Now shear stress, that is the symbol is the tau, because now when a system is tends to slide from one part to another part, the stress develop in the shearing area, that is called the shear stress. Now if you just see that it is resistive force, that means the load, so that is the unit is the Newton. So Newton, and the area, cross sectional area, that is the millimeter square. So unit of the stress, that is the Newton per millimeter square or kilonewton per millimeter square, whatever may be. Now in the case of strain, so strain is unitless. Why strain is unitless? Because it is the, so if we just write strain, so strain equals to change in dimension divided by original dimension. So I just mentioned change in dimension because if we just elongate the member, the length will be increased as well as the diameter will be reduced. If you just compress the member, the diameter will be increased and length will be reduced. So change in dimension by original dimension. So in the case of, if we just consider the length, in that case, so del L by L, that is the change in length by original length. So that is the symbol epsilon. So strain is denoted by the symbol epsilon. So in that case, epsilon can be also written by del D by D. So that is the change in diameter by original diameter. So this is the ratio of the two lengths. That's why this is unitless. So strain is unitless and stress is Newton per millimeter square. Now we discuss this stress strain diagram. Now stress strain diagram. So stress strain diagram of mild steel, that is the ductile material. So there are so many types of material: ductile material, brittle material, malleable material. Okay, so now the broad classification of the material is there are two types. One is the ductile. So material can broadly be divided into two categories. One is the ductile in nature, another one is the brittle in nature. So what is ductile material? So those material can be drawn into wires. Okay. So that type of material, that means we can say that the material, it is the property of the material by virtue of which the material can be drawn into wire. So the example of ductile material, that is the mild steel, MS, copper, so aluminium. So these having the ductile property, that means material can be drawn into wire. So this type of material also having another property, that is the malleable property. So what is malleable property? The flatten into sheets. So mild steel can be able to flatten into sheets. Copper is also the property having the malleable property. That means it can be flattened into sheets. Aluminium also. So these are the ductile material. Now very common example, that is MS, mild steel. So that steel that is generally used in our construction, in our so that steel is called the mild steel. Now the question comes, why it is called mild? So mild means what? Mild means the little bit. So there is a property, that is a small amount of that material is present. That's why it is called mild. So which element is present small in amount? That is the carbon. If the percentage of carbon in the steel is less, that's why, so there is a range. So that's why the steel is in soft in nature. Okay, so that is in, so that steel can be drawn into wires. So if you just increase that carbon content, carbon percentage, what happens? That steel will convert it to the brittle in nature. Brittle means in the Bengali term it is called the bhangur. So that cannot, so it reduces ductile property and increase its brittle property. Okay. So that's why it is called mild steel. So now the brittle material, so those material cannot be drawn into wires. So that material, that means that is the brick, chalk. So when it apply a direct load, so that will not elongate. Very simply way, we can say that brittle material are such type of material, so that will not elongate in the application of the external load, and that is very weak in tension but very strong in compression. So in the case of brick, stone, chalk, glass, these are the material having the brittle material because they are very weak in tension. If you apply a load in the brick, the chalk, and in the glass, in the stone, in this direction, that means in the tensile direction, so it will not take so much of that tensile load with the help of small amount, so it will break easily. But if you just apply this type of force, in the case of brick, of chalk, okay, so this will take much amount of compressive load, but the elongation of the brittle material is very less. Now ductile material and brittle material. Now we go to this part, that is the stress strain diagram of that mild steel first, ductile material mild steel first, after that the brittle material. Now let us discuss. So this axis represents the stress and axis represents the strain. Symbol epsilon, symbol sigma. That is the direct stress and this is the epsilon. Now if you see this diagram, so this is the stress strain diagram of, so just the bottom we just write stress strain diagram of mild steel MS. So this is a ductile material. Okay. Now you see that, so this line is passing through the origin, and there are few points. One is the proportional limit P, this is the elastic point, this is the upper yield point, this is the lower yield point, this is the ultimate stress, and this point is the breaking stress or breaking point. Now I am repeating it again. Proportional limit, elastic limit E, upper yield point Uy, lower yield point Ly, ultimate stress, and this is the breaking stress or breaking point. Now this axis represents stress, so it is nothing but the resistive force by area, that is the, you can write P by A. Now this point is proportional limit. So what is the meaning of proportional limit? So it is a proportion of stress and strain. Well, stress is directly proportional to strain. So we can write stress directly proportional to strain up to this point. Up to this point, stress is directly proportional to strain. Now, just after that point, so it is the elastic point E. So if you see that, you draw a line, so this is the maximum stress that the material can withstand before permanent set of deformation. So this point again I am explaining, that is a very interesting thing. Suppose this is a piece of metal, suppose mild steel, suppose a piece of wire or a rod. We are applying a load from outside, that is the direct load, P. What happened? Due to that direct load, the material will try to elongate. So a resistive force will be developed inside the material. That resistive force will resist. That resistive force will resist or try to resist that external load. If you just withdraw that external load, so material will spring back from deformed state to initial state. That means this resistive force and this applied load, these two are exactly equal up to a certain limit, up to a certain point. Suppose if we increase that applied load P, what happened? That resistive force will also increase, but not so much. So after a certain point, that resistive force will be less than the applied load. After removing that external load, that resistive force will not try to spring back the material from deformed state to initial state. That means there is a point up to that point is varying from material to material. So that point is called the elastic point or elastic limit of the material up to the point. So there is no set of permanent deformation takes place. If we just withdraw the external load, material will spring back from deformed state to initial state. So that point is called the elastic point of the material. So in the case of mild steel, that elastic limit or elastic point is much higher compared to other material. Okay, so that's why in your 10 plus, in your 10 standard, you have just listen the word, a line that iron is more elastic than rubber. So the elastic point of iron is higher than the elastic point of that rubber. Now that means what is elastic point or elastic limit? It is the maximum stress that the material can withstand before permanent set of deformation. That means That means there is no permanent set of deformation. That means this line is passing through the origin, passing through the O. So this is the straight line. Now, that is the upper yield point. Upper yield point. So what is upper yield point? Upper yielding. Now before going to discuss the upper yielding, what is yielding? Yielding means not further increasing stress. The strain increase. Not further increasing stress, the strain increase of the material. Okay, so if you see that there is a starting of the formation of neck. This is the formation of neck. The strain is not increasing, but the stress is not increasing, but the strain increases. The strain increases. Now, from the point where the yielding start, yielding means the deformation. Yielding start, permanent deformation. Yielding start, that is called the upper yielding. Where the yielding ends, that is called the lower yielding or lower yield point. So these 2 points are very, very important. One is the upper yield point and is the lower yield point of this MS, mild steel. Now, they are yielding ends. Now if we just further applying load, further increasing stress, what happens? So, further applying load, so this is the permanent set of deformation. So material will be elongate. Material will be elongate. So that is the upper ultimate stress. So if you draw a line, so this is the maximum stress that the material can withstand before fracture, before failure. Maximum stress that the material can withstand from this diagram is the maximum stress. That's why it is called the ultimate stress. And just after that, material will not sustain that load, so it will elongate and it will fail. So this is the breaking point. So from this starting to the end, so this is the total energy stored by this material, mild steel. Okay, this is the total energy absorbed by the material before fracture, before failure. Okay, now if we just divide this area into 2 parts, so this red line, so this is the E, elastic zone, and this is the P for plastic zone. Now the question comes, what is elastic zone and what is plastic zone? Elastic zone, that means if you just apply load just before point E, what happened? And just withdraw the load, the material will again regain its original shape. There is no set of permanent deformation takes place. But after point E, if you move after point E, there is a permanent set of deformation. Suppose if you just withdraw the load at this point, what happened? So this will not spring back in through this path. So it will just like this. Okay, so this area, this part just after point E, so this part is the plastic zone. Plastic zone means there is a permanent set of deformation takes place. Permanent set. Elastic zone, that is the not permanent, that material can spring back from this state to original state. So this is the stress strain diagram of mild steel. Now another thing is that the stress strain diagram, so mild steel is the ductile material. Now we just discuss the brittle material. What happened in the case of brittle material? Now let us discuss. Now ordinate and abscissa. So this is the stress and strain. So this is the standard symbol of stress and strain. That is sigma and epsilon. So stress strain diagram, stress strain diagram of brittle material. Brittle material. So brittle material, just have discussed that brittle material having the less amount of, very less amount of elongation takes place. So brick, chalk, stone. So these are the common examples of brittle material. Very common example of brittle material. Now we just draw the stress strain diagram. You see that the stress strain diagram of brittle material is just like this. So there is only one point, that is the breaking point. There is the one point that is called breaking point or breaking stress. Breaking stress. That means there is no specific yield point of the brittle material. So another very important significance of yield point means before fracture, before failure, material will show an indication. Suppose if we just apply a load on a brick, tensile load, this brick will not elongate. But after certain load, after certain time, it will break, it will fail, it will fail. That means you only know in which load the brick or the stone or the chalk will break or fail. But before failure, it will not elongate. But in the case of ductile material, before failure, material will elongate. That is the very important property of the ductile material. That means before failure, it will show an indication. Very simple example. If you take a piece of wire, MS wire, apply a direct load, apply a tension, apply a tensile force. What happens? First it will take load, after that it will elongate, it will form a neck. Now if you just draw the diagram, very simple diagram. So this is the piece of wire, apply a tensile force or load, and when it will, after certain amount of load or particular load, it will just elongate, and in this portion, so there is a formation of neck, it will reduce in diameter, and when it will fail, and when it will break or fail, it will form a cup and cone, cup and cone. So this is called cup and this is called cone. So that failure is called cup and cone failure. Before fracture, it will just the shape of that where it will fail, the cup and cone. Now in the case of brittle material, so there is no specific yield point, that's why it will not showing any indication. So only one point is the breaking point, the breaking stress. So this is called the breaking stress. So this is the stress strain diagram of brittle material, just like brick, chalk, stone. And another interesting thing is that there are few materials which behaves, there are few ductile material just like aluminium, brass, copper, like this, especially aluminium. So that aluminium, the stress strain diagram of aluminium is just like the brittle material. So this is the stress strain diagram of aluminium specially. So aluminium is not a brittle material, it is ductile material. But each stress strain diagram, when we draw the stress strain diagram of aluminium, the stress strain diagram of aluminium is just like this, just similar to the brittle material. Now, in that case, how will you calculate its yield point? how will you calculate the yield point of that material? That means the stress strain diagram of aluminium. Now we just take 0.002 percentage of strain and take a point. You just listen this very minute, there is a very interesting point. Just 0.002% of strain, and from this point draw a line parallel to this that will cut this stress strain diagram, and from that you just take a point. So that is called the yield point stress, or this stress is called the proof stress, or yield point stress. So in this way, you can able to calculate the yield point of that aluminium. Okay. Now this is the overall stress strain and the stress strain diagram of ductile material, brittle material, and as well as aluminium. Okay. Thank you very much.